Okay, so we're going to show, this is going to talk about how to show universal statements are false. All right, so a universal statement means this, right? For every x in D, like if P then Q, or some kind of statement, right? So to disprove is to show this statement is false. So to show a statement is false is the same as equivalent showing its negation is true. All right, so the negation of this, right? The negation of this would be this. There exists an x in D such that P and not Q, right? Because you take the negation of an if P then Q. All right, so I'm going to give you an example. Because this is an example to show that the original is false, we call it a counterexample because we find an example to show it. Okay, so here we go. So we're disproving this. For all real numbers a and b, if a squared equals b squared, then a equals b. So I'm telling you to disprove that because you know it's not true. So what you do is we're just going to walking through what seems like a simple thing, but a process. So first, we're going to start with the negation. Take the negation, which would be there exist real numbers a and b, such that, and I guess, yeah, such that, remember, if you're taking the negation of an if-then, there is no if-then, right? Such that this and not this, right? Okay, so now give the example. So a equal 1, b equal -1 works, right? Because if I take a squared, it equals b squared, but a doesn't equal b, right? So that's showing by a counterexample it's not true. All right, so proving universal statements. So proving it works all the time. So there's two ways, method of exhaustion or direct proof. So let's just do exhaustion first. So the method of exhaustion, just so you won't have to do this very often, but this is what it means to do method of exhaustion. So this is proving for all integers n, if n is even and n is between here. So you're going to have a restriction. You can't say for all n's. You're going to have a restriction on the range. Then n can be written as the sum of two prime numbers. So out of these numbers here that are even, right? So in this range between 4 and 12, you have 4, 6, 8, 10, and 12. Those are my even numbers. So can you think of how to write these as the sum of two prime numbers? Well, here we go, 2 plus 2, because 2 is the first prime number, right? 3 plus 3, then 5 plus 3, then 5 plus 5, and 7 plus 5. Okay, so that's the method of exhaustion. I showed that each of these numbers could be written as the sum of two primes. Okay, so here we go on the direct proof, and we're going to be doing many more of this kind. So like this. So prove that the sum of any two even integers is even. Okay, so this is what you're going to have to do. You're going to have to formally restate this and say, okay, so for any m and n integers, and it's like in English, you could write this a little bit different, right? You could also say for every m comma n element of integers, right? If m and n are even, then m plus n is even. So you need to kind of come up with this. Then, if, then. Okay. So our next step would be to use the definition of even for my m and my n. So m is going to be 2k and n is going to be 2t. Okay, notice, big deal. You cannot use the letter k for both m and n, right? Because that would mean that they're the same, right? 2k is 2k. So we can't do that. So notice I let k here and t here, and I said on the side here, these two, k and t, have to be elements of the integers. So lots of details here, just making sure we're going through it. Okay, so the next step would be to add my m and n, substituting in my 2k, right, going back up to here, not this, right, my 2k and my 2t. So m plus n is 2k plus 2t. Then I factor a 2 out and I get t plus k. So then the next step would be let P equal T plus K. And what I've done is I've written M plus N as 2 times P, where P is an integer. That means it's even. So this is what we'll be doing a lot of. So let's just kind of go over the steps again. Formally restate it so you get some letters in here, right? M and N. If M and N are even, then M plus N is even. Use the definition, right? And this thing on the side here is important. Then start with M plus N, make the substitution, then factor out the 2, and then rewrite T plus K, let that be a P, so that I get that M plus N is equal to 2P, so that's even.